Hello everybody, hope you've been doing okay. I know I promised to make videos more frequently, but then it so happens I've been really busy, and then these videos take a lot of time to make, so I guess that's why I've been having some delays. But then the major thing we're supposed to discuss, there are many other videos that were made, but then I felt we should jump into the organic chemistry and then we'll upload the rest of the videos later on. So what is organic chemistry? Organic chemistry is the study of compounds of carbon that we generally call hydrocarbons. So you need to know that these hydrocarbons are generally divided into three major families. So we have alkanes with an A, and then we have alkenes, and then we have alkynes. So the major distinction between these three families is the idea of bonds. So you need to know alkanes do not have any double or triple bonds, whilst the alkenes have double bonds in them. Alkynes with a Y have triple bonds. So these are the three major families when you talk about hydrocarbons, and they are all fractions of petroleum. So you can separate the components of petroleum via a process known as fractional distillation. I'm sure we still remember what fractional distillation is. So organic chemistry is the backbone of drug synthesis. Very important, because you'll be able to see when you look at courses like pharmacology, pharmacognosy, you'll be able to see that all active pharmaceutical ingredients or drugs are carbon based at the end of the day. They all have a carbon structure or a carbon moiety of some sort with various functional groups attached. So it is very important that a pharmacist has some level of understanding of organic chemistry. So organic chemistry is therefore imperative to pharmacists. Now, before we dive deep into the idea of organic chemistry, it would be very important for us to discuss some terminologies. The first terminology, homologous series. This is a term I'm sure you've heard of at some point. If you've taken a chemistry course, maybe at secondary school, so this is a word you've come across. So what does it mean when you say homologous series? So this refers to a family of organic compounds that follow structural patterns having similar properties and only differing in a CH2. Now, what am I trying to say there? What I'm trying to say is that the members of this family will be in such a way that the difference between one member and its consecutive member is just a CH2. Meaning if I remove a CH2 from one member, I'll get the previous member. Examples: alkanes, alkenes, alkynes, alkanos. So when they say alkano, they mean alcohol. I guess I don't know who coined that word, but turns out they mean the same thing. So the next terminology is functional group. What's a functional group? Functional group refers to an atom, bond, or radical that is common between members of a homologous series and determines the properties of that homologous series. We'll talk about functional groups more in detail. So we'll talk about carbonyl compounds, we'll talk about epoxides, we'll talk about esters, we'll talk about ethers, we'll talk about amides, we'll talk about amines. Those are examples of functional groups. The next concept is the idea of saturation. Saturation is a word we've heard so many times. You know, we say, saturated fat, unsaturated fat. What are we trying to say? The concept of saturation is, it refers to the presence of double or triple bonds. So alkanes are saturated. This is because they lack double or triple bonds, whilst alkynes and alkenes are unsaturated. So when they say unsaturated fat, they are literally referring to fat that has some double or triple bonds somewhere in the structure, right? Hybridization is the next term. Hybridization is a very important concept. I'm sure you've come across this one when you did your inorganic chemistry. It refers to the mixing of two or more orbitals of the same principal quantum number in order for them to form other orbitals of similar energy. I'm sure you remember what the principal quantum number is. So we said when we described quantum numbers, we had several quantum numbers. We had the principal quantum number, azimuth or magnetic quantum number, the spin quantum number, right? The principal quantum number gives you the number of shells So that's another way of thinking about it. You could think of it as shells. When we talk about alkanes, their hybridization is sp3. Anything that's sp3, what's its geometry? To be tetrahedral. If it's tetrahedral, the bond angle will be 109.5 degrees. Alkenes generally will be sp2 hybridized, and then the bond angle on a molecule is sp2 hybridized will be 120 degrees. So generally sp2 hybridized, not always, but generally they'll tend to have a trigonal planar geometry, and then this is why you have that 120, because 120 by 3 will give you 360, right? So alkynes are typically sp hybridized. They tend to form linear compounds. This is why the bond angle is 180. The next concept we need to discuss is the idea of bonds. So bonds are very, very important. Bonds generally are of two types. So you can either have a sigma bond or a pi bond. A sigma bond, this refers to the overlap of atomic orbitals in a head-to-head fashion. So generally sigma bonds are very strong, and because they are strong, they contribute to the strength of double, triple, and single bonds. So you'll find them in single, double, and triple bonds. Now, pi bonds are not formed by direct interactions. Instead, they are formed by the attraction between two orbitals in a side-to-side manner. So you'll be able to see these bonds are formed in a side-to-side overlap of atomic orbitals. For this reason, because there is no actual interaction, they are generally weak. And then sigma bonds only occur in double and triple bonds. That's another thing you need to know. So the next thing we'll talk about is the formulas. So the general formulas. You need to know all the three families I mentioned before have general formulas. For alkanes, we say CN H2N plus 2, right? And then for alkenes, we say CN H2N. And then alkynes, we say CN H2N minus 2. And then you need to know that sometimes you have cyclic compounds like cycloalkanes, cycloalkenes, and cycloalkynes. So when you have cycloalkanes, it's the same formula as the alkenes, right? All that you need to know is that you can never have a cycloalkane that has less than 3 carbons. So the carbons need to be equal to or greater than 3. So 3, 4, 5, 6, 7, and so on. Then when you talk about the cycloalkenes, that's their general formula right there. You need to know that generally 3 is okay, although whenever you create a cycloalkene with 3 carbons, it's very difficult to synthesize. The synthesis methods are very hard. It's possible to synthesize them, but then the cycloalkene with 3 carbons is very, very unstable, right? The fact that it's unstable means it will tend to react and form another compound. So generally you won't see too many cycloalkenes with 3 carbons, maybe 5, 6, 7, and so on. And then when you talk about cycloalkynes, cycloalkynes cannot exist with 3. Like 3 is generally unlikely. 4 is also unlikely. So you need a minimum of 8 carbons for you to have a cycloalkyne. So 8 and above, you have a cycloalkyne. I think that was an important point there. Now, the most important thing is, how do you name these guys? Like, how do you name them? So generally, naming all the 3 families, we have the same rules, although generally the trend of how they are taught is they'll talk about alkanes and they'll teach you how to name alkanes. Alkenes, they'll teach you how to name alkenes. Alkynes, but I feel that's really time consuming because they're literally saying the same thing. So I decided to summarize everything in one PowerPoint. So if you want access to the PowerPoint, all you have to do is leave a comment down there and then I'll be able to send it to you. Yeah, I'll be able to get in touch with you and then I'll be able to share my PowerPoints with you. Yeah, so how do you name alkenes? So the first thing you need to know is whenever you're naming alkanes, alkenes, or alkynes, the first thing is you need to know the suffixes that we use. So for 1 carbon we use meth, for 2 we use eth, for 3 we use prop, for 4 we use bute, for 5 we use pent, for 6 we use hex, and you can see the rest right there. If it's an alkane, you add the prefix ane. If it's an alkene, you add the prefix ene. And if it's an alkyne, you add yne. That is something I expect that you know at this point, at least, right? This is something you know intuitively. So an example would be if you wanted to name something with, let's say, 5. We said 5 would be pent, right? If you're able to see right here, we say 5 would be pent. So if it's an alkane, you say pentane. If it's an alkene, you say pentene. If it's an alkyne, you say pentyne, right? However, it's very important for you to know that whenever you say something is an alkene or an alkyne, there's a double bond somewhere. And then because there's a number of places those double bonds can be, saying pentene or pentyne alone is not enough. Instead, you need to add a number to specify where the double bonds are. So an example you'll be able to see there is when you say pent 2-ine. What are you trying to say? At position 2, there's a double bond of that alkene. And then when you say pent 1-ine, what are you trying to say? You're trying to say at position 1, there's a triple bond, right? So we have pent 2-ine and pent 1-ine. Those are examples. Do this exercise for me. So if you've understood what we've learned today, and if you got those general formulas, it will be very easy for you to answer these questions. So we say whether the following are alkanes, alkenes, or alkynes. Please pause the video and try them out, and then we'll be able to answer them together.